Okay, so I'm going to start with a short slide deck that just gives, this is David again. So I'm going to do a quick slide deck that gives a background on OpenStudio, and then we'll move into more of a demonstration, starting with the Sketchup plugin, and then OpenStudio, and then we'll talk about, Rob will talk about the Radiance work. Please, I know it's a little tricky on the webinar, but we can take questions as we go, or questions can come at the end as well. So some of these slides I'm going to kind of skip through. This just shows some collaborators that we are working with, both with CRADAs, partnerships, and just collaborators. This includes other national labs from the United States as well as Canada. You can see NRCan at the bottom of that. And then we also are working with a number of utilities and private companies. This is just a little word cloud showing some of the users of OpenStudio. And you can see NREL.gov is one of the biggest ones. So we have a lot of internal modelers, and so we use it a lot. You'll see a lot of universities as well as design firms there as well. And at the bottom there is a note we filtered. This is just based on the domains that people registered from, and so Gmail and Hotmail and Yahoo were giant, and so we've hidden those in the view here. But this gives you an idea of what kind of user base we have.
Yeah, it's a pretty broad base, both geographically and sector-wise.
And our audience is actually pretty wide, and this slide starts to get into that. We have expert users who are researchers who are developing large-scale analysis, and then we also just have beginning modelers who are just trying to model a basic building. And so what this slide is showing is we have different interfaces at the left for beginning users, and as you move towards the right for more advanced users. And the Sketchup plugin and the application I'm going to show today sits in the middle. The web interfaces are actually more basic interfaces that just ask you a few questions on a website, and it can run the simulation without you having to install anything on your computer. So OpenStudio is kind of a core software development kit. So OpenStudio gets thrown around a lot. Some people thought it meant the Sketchup plugin, but it's now this larger development project which has a core, and then it has interfaces that sit on top of it, and they're kind of all part of OpenStudio. One thing OpenStudio is not is a simulation engine. It passes off your model to originally Energy Plus, and now additionally to Radiance, and then we are working on other simulation engines, support for other simulation engines as well. The idea being that to make energy modeling efficient throughout the design process, it needs to be easy, and you need to have a single model both for minimizing the design effort or the modeling effort, as well as making sure your models are in sync so that you're comparing apples to apples.
Yeah, that's one of the big goals of OpenStudio is to present the users with a middleware that actually does a lot of the modeling integration for you. So you build your model in OpenStudio, but when you actually run a simulation, we rely on other vetted, high-quality tools such as Energy Plus and Radiance to do the actual simulation work and inform one another of what's going on vis-a-vis the daylighting or the mechanical systems, etc. And you see that gray bar on the bottom right that says Others. The others, even the Radiance functionality, are great examples of applications of the OpenStudio middleware. Right? OpenStudio just provides you with a model, a simulation tool agnostic building model that can account for anything that you might want to simulate, whether it's windows or mechanical systems or daylighting. So Radiance is really the first project that leveraged this middleware. But we have some graduate students that are actively writing translators to other simulation tools such as Contam, which just directly use OpenStudio to do the translation. So you make your model in OpenStudio, but then when you want to do a natural ventilation study, you export it to Contam using all the OpenStudio tools.
So this slide just shows the process in the Sketchup plugin, which is the tool that we use to create your geometry. So this is actually built on Trimble Sketchup, I think, as of June 1st. It used to be Google Sketchup. So it's still free for commercial use. Since our software is free, we wanted to build it on top of a geometry tool that allowed people kind of an easy entry point without having to invest a lot of money in the software. And also, as important for SketchUp, you don't have to invest a lot in learning how to use the software because it's got very easy tools that have a low learning curve. And so on the top, we start by just drawing a diagram of our building, the footprint, and then we can extrude that up into a building. We can add fenestration. And then on this bottom right section here, we start assigning attributes to these spaces about what activity goes on there, what thermal zone they belong to. And from that point, we then move into our OpenStudio application. This slide just shows that we have support for GBXML. So if you're working in Revit or other applications which either import or export GBXML, you can use that as a starting point as well. And it brings in not only geometry, but some of the data behind that, like the constructions and the boundary conditions and space types or spaces. Other options for geometry is actually working with photographs. And these photographs can be photographs you took. Sketchup has something called Match Photo that at the top left shows you how to basically trace over a photograph and create a 3D model. This slide here shows that we can import Google Earth content to use adjacent buildings for shading of our model. This here is another. This is the RSF that NREL is at NREL. We actually have a third wing now that when I photographed this didn't exist yet, so it's growing. Google has something called Building Maker. They use oblique aerial photographs that are on a server, and you can basically use an online web tool to make a 3D model, and then that imports into SketchUp. And then, of course, you can work on floor plans. So this is just showing that there's a lot of entry points based on how you want to do your work that all get you to the same spot. So we've recently been working with a lot of the users to look at what barriers stop them from implementing energy modeling into early design. And so this included members of the American Institute of Architects, RMI is a local research company in Boulder, and then researchers and educators. And a lot of people wanted a single application. We used to have 4 or 5 applications, and what you're going to see in this demonstration is that we're trying to wrap a lot of that into a kind of single application or 2 applications, and then have a prescribed workflow that kind of walks the user through that so it's easier to follow. And so this is that application. So once your geometry's in, you have this application here that has a series of tabs over at the left. And as this arrow suggests, you start at the top, and then you work your way down through those tabs. And then many of them you skip, but they allow you to drill down and get into as much detail as you want, which in this case is showing a lighting schedule for a large hotel, broken down over a 24-hour day profile. And this interface that I'm going to show has a lot of drag and drop functionality. And in this case, we're showing a library. You can either load from your library or your model, and you can take objects, for example, constructions, and drag them onto a construction set, which defines what kind of construction you want for an exterior wall versus an interior wall.
And another thing to point out on this slide in particular is obviously down towards the bottom is what you guys would be probably most interested in is the window constructions. So are you going to talk about the BCL?
Yeah.
Detail? Okay. So David's going to talk about this other NREL project called the Building Component Library in a little bit, where we anticipate you guys would probably be most interested in. It's a library of, or it's a repository, I guess, of building energy model components. So that could be anything from a chiller description to a weather file to a window construction. So David will get into detail on that. Are you going to do a demo of the drag and drop stuff?
Yeah, but not the BCL drag and drop.
Okay.
But I'll.
But yeah. So David's got some detailed slides for you later about this BCL project, which I think is quite relevant to you guys. Sorry,
yeah,
go ahead.
That's right. And so with the other thing important down here, you can start to see what Rob was talking about, the subsurfaces, which is fenestration. You can have a set construction for fixed windows versus operable windows. And if a user goes and downloads something from the building component library, they just drag it into their project. And instead of having to assign windows or constructions to every individual window, you can just globally set them for your entire model or for a space or for a story. So this allows people to do what-if analysis, where you change any windows that have a U value below something to another window. So you can put in some advanced logic if you start working on some scripts to manipulate your model that way. This is just an example here showing what the interface looks like for adding mechanical systems. There's a lot of templated systems, and you can just add them to your model and then hook up the zones that you want to use with them. And this shows that once you drop one of these in, it's custom. You can customize it. And in this case, I'm clicking on a air conditioning or a compressor, and then you can change the efficiency of that or other attributes of that. And this is an example of the results you get out of this application. So at this point, we've worked our way to the bottom tab. Excuse me. And then you get these results showing heating and cooling, and then lighting, electricity, and then we have fans and pumps. In this case, fans, I guess here. And then we have electric consumption broken down from gas. If you want to dig into much finer detail, you can click this button here, which launches a results viewer application, and it lets you see annual time series data in 15-minute time steps. So this gets into Rob's Radiance work again here, and this is an example of one of these time series plots you can make in the results viewer application. Do you want to a little to the slide, Melissa?
Sure. Yeah. So just really briefly, we at NREL have identified a somewhat significant technology gap in the difference in rigor of how daylighting and electric lighting are simulated with dedicated daylighting tools versus whole building energy simulation tools like Energy Plus. So a big part of this year's work and hopefully next year's work is integrating Radiance capability into OpenStudio. So the idea of using a 20-year-old validated and still being updated lighting simulation tool to do the daylighting simulation, and then use that data to inform the whole building energy model. So to that end, we've added objects into OpenStudio that support this kind of analysis. So energy models typically don't really care about the interior of the physical geometry of the building model, partitions and the like. But a daylighting model obviously cares a great deal about that kind of stuff. So we've added objects to the OpenStudio model to support radiance simulation, such as air walls, where if you have, typically in an energy model, your thermal zones dictate the boundaries of the spaces, but those don't necessarily correlate to actual physical geometry. So we've allowed an object called an air wall, which is a thermal zone boundary that doesn't actually have an architectural counterpart to it. So it's, in other words, it's an energy modeling construct, but it's not like, it doesn't represent an actual wall or physical geometry in any way. Likewise, we can also put in interior partition objects. So you see in the model in the lower left, we've got a desk and a couple of cubicles represented there. Those are things that you just don't do in an energy model, but you need that kind of stuff for the daylight model to be accurate. So OpenStudio allows you to put those objects in, and when you do a radiance analysis, those objects are exported into the radiance model, but they're completely ignored or they're represented in a different way in the energy model. So that's kind of what that slide is trying to show. And then we have translators built into OpenStudio so that you can build your model in the Trimble Sketchup plugin, and directly export a radiance model, which the lower right image is a rendering of the same model as it existed in OpenStudio, and then in the upper right is just what we call a temporal plot of the daylight availability for that space. So what that's showing is on the X is the day of the year, and on the Y is the hour of the day. So what you're seeing is a 8,760 schedule of the foot candles or the illuminance from daylight over the course of the entire year. And these are the kinds of analyses that are really needed to do a rigorous daylighting analysis, and those tools now exist in OpenStudio.
So I think there's not much to say on this slide other than we're trying to make things quicker, more reliable, and obviously the data going in has to be good, and the building component library is part of this. Where do you get good data for a particular window? If users try to make that up on their own, there's not a lot of reliability in the results. So this is the building component library, and I'll go to this website later. It's actually live now with HTTP, well, it's bcl.nrel.gov. We're continually adding more content to this, and in the future the idea is that third parties will be able to add their own content as well. And then, much like Amazon, you can do faceted searches. It also has a social aspect where you can rate or comment on components that other people put up. And then we're integrating this. This has an API that both OpenStudio as well as other software developers can integrate into their own software, so that you won't have to go to the website and get these. You can download them directly from within the application. Another thing we're going to have here, other than objects that Rob mentioned like Windows, is something called energy conservation measures. And I'll show something like this in the demonstration where you, for example, change all of your windows on the south face to a certain window-to-wall ratio, or rather change your, so you might delete your existing windows and then draw a ribbon window that meets this desired ratio. And so you can do that over a large building or over a set of models all at once.
Or you could use this to automatically do a sensitivity analysis based on, U value, for example, or T-Viz versus solar heat gain coefficient, etc.
Okay, I think I'm going to skip over this. We've kind of talked about some of these, but you can do mechanical systems as well as envelope type of measures. And this is an example of actually changing the building geometry based on a script like that.
Yeah, so can you go back?
Yeah.
Sorry. So the point to take away from this is that all these models were generated procedurally. So the modeler, the high-paid energy modeler, creates one, we call them seed models, which is sort of a base building. And then with scripts, you can actually automate the perturbation or the change, the variable change, whether it's window-to-wall area ratio or T-Viz or U value or whatever it is. And that's all done automatically with a script. So you can really do some rapid sensitivity analyses this way.
So this is just showing the integration of the building component library that's going to come in the application where that library will pull from here. I see this blinking comment here. I'm just going to see if there's nothing. Oh, try to speak slower.
Oh, sorry.
Okay, I'll do that.
We both have that problem. Sorry.
Okay, so I'm going to jump into the demonstration now. These other slides here, I don't think we even need to come back to. So I know the internet connection is a little bit slow, so I'm going to use Sketchup, which is a 3D application, and I'll try not to navigate around too quickly so that you'll have a chance to see the dialogue come up. So I have an empty model now. On the left is SketchUp's toolbar, and it's stayed very much the same over 10 years, where you have basic tools like a rectangle tool and a pencil and an eraser. And then down here by this hand are the navigation tools to navigate around your model. Up at the top is the OpenStudio toolbar. And actually, we have many more tools here than you need to use since we've automated a lot of things. But the first thing I'm going to do is at the top left is click the button to make a new OpenStudio model from a template. And I'm not going to save my current model. Here we have 16 different types of templates. And these were based originally off of the Department of Energy reference buildings. And so they had 16 different building types across all of the U.S. climate zones and 4 different vintages of buildings. So each of these templates, they don't have geometry, but they're preloaded with the constructions and the schedules appropriate and the usage patterns of lighting and occupancy that are appropriate for that type of building. So I'm going to choose large hotel. At the bottom, you can see a progress as it's loading that in. And now I'm just basically going to draw the footprint of my building. So I'm going to use the rectangle tools to define that. And I'm going to click next to Susan, our scale figure here. And I'm going to click a point to start my rectangle, move over to the right. And if you notice in the very bottom right, there's a box that says dimensions. And as I move, that adjusts. And I'm just going to click this rectangle wherever it is. If I want to do a precise size, before I do anything else, I can actually just type 100 feet by 50 feet and hit enter. And it will resize my rectangle to be the precise dimension. So you can just loosely draw things, or you can precisely type in the dimensions you want. And so now I'm just going to click this little magnifying glass with arrows to zoom all the way out. And I'm going to use the orbit tool to orbit a little bit higher so that you can see this shape. So this is the overall outside footprint of my building. I'm just going to use the pencil tool now to slice it up into pieces. And Sketchup has an inference engine, so you notice it'll find the midpoint as I get close, and the dot turns blue. So I'll just split this in half. I'm going to draw a 5-foot line here so I can make what is going to become a corridor. And then in the front, I'm going to split this in half. So this is going to be kind of an odd hotel, but I want to keep the model basic for the demonstration. So at this point, these are just loose SketchUp surfaces. They don't know what they are. They're not OpenStudio elements. I can I can go to Edit and select all, and that will select all of the surfaces. And we have a tool here that looks like a little plan that says Create Spaces from Diagram. So when I click that, it's going to ask me what I want for floor-to-floor height and then how many stories or floors I want my building to be. So I'm just going to make it a 2-story building with 10-foot floors. And it will go ahead and create OpenStudio spaces for each of those diagram pieces. And if I click one of these, I can double-click and go inside of it. I can actually hide the rest of the model. So you can see each space on its own, and they each have surfaces separating them from the other space. The first thing I want to do is for Energy Plus is to create thermal connections between these spaces, and so we have something called surface matching. And just to show you what this means is we have different render modes. The first render mode I was in is render by class. And walls look like walls, roofs look like roofs, and we even have a special color for windows. So as you draw windows, they'll be transparent because they get classified as a subsurface, and all that happens automatically. This other render mode renders by boundary conditions, and this tells you when you run the simulation what is the surface exposed to the ground temperatures, to the air temperatures, or some other interior surface. And so right now blue represents outdoor, and at the bottom here the tan color represents ground. So if it's 90 outside, I don't want this particular surface on the right to be 90 degrees because it's next to a zone or space that's also maybe 70. At any rate, so I'm going to run the surface matching. It's going to go through the model and it's going to find all of these connections. And now if I go back, you'll see a green color on all of these interior surfaces. And so it's now made the thermal connections that Energy Plus will use when you run the simulation. Some other things that does is when we run scripts that we want to do something just on exterior surfaces, it now knows which surfaces are exterior versus interior. So as an example, I'm going to draw some windows here. And I just drew at one window. But you can also import CAD files, or you can just hand draw a bunch of loose windows that are not part of an OpenStudio space. It's very much like the diagram I drew at the beginning. And I can project these onto my geometry. And so it will make them into subsurfaces and then classify them and assign them a construction. But one thing I want to show an example of here is the building measures that we talked about in the building component library. I can select my entire building, and I can go to some user scripts we have. And some of these are example scripts that we have written, but users can extend these and write their own. And this content is going to be moving up onto the building component library, so you can just download it through that and use it. And in this case, what I want to do is set window-to-wall ratio. So it will ask me for a fraction and then an offset value, which is either above the floor or below the ceiling. And so I'll leave the defaults in here. And it will go in for me and delete all of my windows and then recreate a ribbon window that meets the requirement that I asked for. And you'll notice it didn't do any interior windows because we've matched that together. But this is kind of a broad stroke. So normally you're going to want different ratios on different sides of the building. Something we have in the plugin here is a surface searching. And so this will allow me to do something, for example, to search only for subsurfaces. Oops, this wants me to autosave. We'll ignore that. Only subsurfaces with an orientation of 180 degrees. This can be a range or this can be just a set orientation. So when I search the entire model, not only does it hide the rest of the model, but that little, I don't know if you can see it on your screens, but there's a little dot pattern to let you know that those windows are selected. And then the rest of the model that you can't see, you can expose here with this button. So now I'm going to go to plugins and use a similar script that just assigns overhangs or adds overhangs to windows with a projection factor and then an offset value. Because I've selected only the south windows, this will only run on those windows. And if I go back and unhide the rest, I've been more selective now and just applied the overhangs to a specific window. So you could take that same logic with the windows as well. Okay, so I'm just going to save this model. It's good practice to save from time to time in case you need to go back to an older one. So my envelope is pretty well set here. I haven't talked about constructions much now, but when we move into the OpenStudio application, I'll show you how those get assigned. But what I want to move into now is building activity. So we have another render mode that's render by space type. So remember, we loaded in templates that had a lot of data. So some of that data was for a hotel. How many people are in a guest room at different times of day? How much electricity are they using? You know, you can even change the activity level for if it's a gym and they're more active and they're producing more heat. All that can be customized. So by default now, we picked them on our templates the most common building space type for a building and made that default. So if you don't assign any spaces, everything here is going to be a guest room. And we have a little info tool, which is this arrow with the box. And it's aware of which render mode you're in and will show you the right data. So this one shows you the space type, which we have made some changes. So the space type, I noticed, isn't all that meaningful. But you can see the name down there. It's a climate zone 4 through 8, 2009 guest room. So I'm going to leave these 4 spaces here at the side, and I'm going to let them be guest rooms. But I'm going to pick these 2 middle spaces here, and I'm going to make those a corridor. And so the way I do that is I select 1 or more spaces, and we have another button here called space attributes. So when I pick that, I have a number of things I can change. And in this case, I just want to change the space types. So I'm going to pick from a pull-down list here, and I'm going to go to corridor. And because I'm in a render mode that's specific to the space types, you'll see the render colors change based on that. And these are user adjustable colors. We've preset our templates where private spaces are warm colors and public spaces are warm and private spaces are cool colors. But the users can match that to their architectural firm's standards for floor diagrams. So I'm going to change this to a lobby over here, and then we'll make this a banquet area on top. So this is really powerful. I mean, you're attaching a lot of data to this model and making it almost ready to run just by assigning the activities in the different areas.
And one thing to note too is that this data, like for example, occupancy schedules, is being applied to this OpenStudio model. But then if we choose to do an energy simulation, that's automatically passed through to the energy simulation tool, Energy Plus. Likewise, it's also automatically passed through to Radiance. So when you're doing a daylighting analysis, it derives its occupancy schedule directly from the OpenStudio model. So the assumptions that those things are based on are synchronized across all of the models, the energy model, the daylight model, et cetera.
Okay, that's right. So now I'm going to switch to one more render mode here, which is render by thermal zone. So Energy Plus, thermal zones don't necessarily represent rooms. It can be a collection of rooms. And the nice thing with OpenStudio is we've kind of decoupled the assignment of activity from the thermal zones of the building, and that you can divide up your building exactly how it is, and then later on you can come back and just say, I want these 2 spaces to be part of a single thermal zone. And so I go to the same space attributes that I used, but in this case I'm going to use the thermal zone, and I'm going to make a new thermal zone that includes those 2 spaces. Now I'm going to do one thing here. In this case, I'm picking spaces of the same space type, and I'm adding them to a single thermal zone. Where this becomes really powerful is what I'm going to do in this 3rd zone. I'm going to go and take a corridor and a banquet area. And they have different schedules, they have different internal loads, but I'm going to make them part of one thermal zone. Now in the past, a lot of people would keep a spreadsheet of what spaces go into the thermal zone, and that would be separate from their model. Let me see if that's, every now and then our random color assignment gives a color that looks like the last one, so I'm just going to go ahead and change that. There's a paint bucket over here, and I can hold down the Alt key and then assign a new color for that. So just to show that that is a separate thermal zone from the other one. So what will happen is when we make a thermal zone, we'll add the loads from the corridor and the banquet, and we'll make a weighted average, or that's actually an additive process to put those together, so that you don't have to keep the separate spreadsheet to explain to people where you got the values for your thermal zone. It's a more traceable, transparent process. So these last two zones I'm just going to put on their own. So you don't necessarily have to combine spaces in a thermal zone. Each space can be its own thermal zone as well. And in fact, if you are working with an IDF file as a starting point, that is how that will happen. Let me go back and change this so we can see that this one was done as well. That's all right. We'll leave that on. So at this point, we're pretty much done with the Sketchup plugin. The only thing I want to do here is go ahead and assign some thermostats. So the same tool I've been using here, this space attributes, allows me to do two things. I can turn on something called ideal air loads, and this allows you to run a simulation without having to design a full mechanical system, and it'll tell you how much energy is required to maintain the set points you have, given the internal and then the envelope, the external loads that are on a space. And you can pick a thermostat to go with this. So I'm just going to pick the generic large hotel thermostat, but we do have extra thermostats for different space types within the templates. And then you can configure those in the OpenStudio application to match the schedule for your specific project. So if you open 2 hours later, you can just adjust the schedule to represent that. So I'm just going to save this file again. I'm going to give it a new name. And I'm going to click a button here we have that looks like a little OS icon. And so that will actually launch the new application, the OpenStudio application, with our current model. You can manually launch that as its own application and just go to File, Open, and pick an OSM file. But this just gives you a nice workflow if you've been in the Sketchup plugin to jump over there. So it starts us at this first tab. And before I jump into the tabs, I want to just show you that there is data in this model. There's a facility tab here that looks like a building. And it shows you kind of a tree view of your model, which should come up here in a second. So I can expand this out. And it will start to show me the different stories of the buildings and then which spaces are under those stories. And then I can click a space and I can see what thermal zone it's in. This is the space type assignments I made. So this one has the corridor space type assigned and then what story it's on. And then I can even drill down here into the walls and then subsurfaces to find out what is assigned for the windows. And this shows you the construction that's assigned for that particular window. And I'll explain a little bit later how that works. But anyway, to start with, I'm going to go back to this first tab. And we need to pick a location for our building so that Energy Plus knows what kind of weather files to simulate here for the building. So I'm just going to go to Energy Plus installs a few example weather files, and I'm going to pick Chicago. These weather files will also be on the building component library, and you'll be able to search based on zip code or address, and it'll offer a few choices of the weather files that are closest to you. This DDY file is actually this design day files, and this is used when you're sizing equipment to determine kind of worst case scenarios for the equipment, as opposed to an annual data, which is in this first weather file. So now that I've done this, I can actually save this file here, and while I'm doing other stuff, I'm just going to let this run. So again, all these tabs let you alter or inspect your model, and then you can skip down to the end. The second to last tab runs your simulation, and then the last tab shows you the high-level results. So while that is running, I'm going to go back to this tab for a bit here. So if you've ever, I don't know if any of you have worked with Energy Plus in the past, but generally every single surface in your building needed to have a construction assigned to it. So if you have 250 windows, for each one you would need to go in and you would need to find a construction. And it wasn't drag and drop. You'd normally have a pull-down list of some sort. And you would just drag this over for each one. I'm not going to drop it. You'll notice it turns into a plus when I'm on a drop box that it'll accept. But what we do here is we do something a little different. at this, the building level, the top level object, we can set a default construction set. And so that default construction set says, for exterior windows, use this construction. For interior windows, use this. And you have like floors that have a ground boundary condition versus roofs versus an interior floor. And so everything you can think of, there's a different construction set for. If you have a particular story of your building, for example, the first floor has maybe a window that is different than stories above, you can actually go to the story object and assign an overriding construction set or schedule set. And then you can again drill down actually to a space or space type, or even to an individual surface. And so let's say this surface has a piece of art glass that's in the window. Let me see if the simulation's done running. Then I can mess with the model. I don't want to mess with it if it's running. Okay, it looks like it's done. So this actually shows you, because we used ideal air loads here, our heating and cooling is using something called district heating and cooling. We don't actually know what fuel it is. So you can see your heating and cooling down here on this table. In the future, we're going to add graphics for this as well. So all we're seeing on the chart here is basically consumption for lighting and for electricity, which you can see does have some annual changes. February seems to drop down. Of course, it's a shorter month there as well. So anyway, now that I know it's not running a live simulation, I apologize for this interface being slow. I'm on a development build. So I'm going to go back here, and I can drop a construction here. And instead of being green, it will turn black. And that black lets me know that I've assigned that construction to that actual surface as opposed to being inherited from a higher level. And then if I click the X, it goes in it, and it looks up the chain until it finds a construction at the story or the space, rather the space or the story or the building, and then it uses that when you export to either Radiance or Energy Plus. I'm going to spend a few minutes here talking about mechanical systems, but then I'm going to go back up to these resources and particularly constructions and schedules, where I think you all will be more interested. So we have 8 spaces in our model, but we actually only have 5 thermal zones. So you can see here, let's see, I'm going to close this. So here you can see the 4 spaces on each story, but we've combined them, so that's why there's only 5 thermal zones. And each of those, you can see that they have thermostats, and if they don't have thermostats, you can go and you can drag schedules on heating or cooling step 1 schedules. And then once I've done that, I can go and I can pick a template mechanical system. And these are based off of ASHRAE Appendix Type G, which are just some standard types. And so this one here that I'm going to pick has a heating and cooling plant and a variable speed fan, and it has some hot water reheat for the terminal. So basically, I click one button. It adds this into my model. I can look at this object, which is a fan, and I can change the fan efficiency. And this object here that is a cooling coil actually has a hyperlink to the plant loop that was made with it. And then you can click on, for example, the pump and find out information about that, and then jump back to your air loop. So basically this diagram here is showing a loop. And whether it's a plant loop or an air loop, the bottom represents the demand side, and the top represents the supply side. So here, the cooling coil is actually a demand object, and it tells the plant that I need this much cold water. Now that we jump to an air loop, and you can see the name of the loop over here, now this is actually a supply side object, and it's the thermal zone that we're going to put down here, or thermal zones that we're going to put down here, that become demand objects. And as they have more demand for cold water, then this coil will request that from the plant. And so all this happens kind of behind the scenes. But this task of adding this diagram for the mechanical systems in the past may have taken like a whole afternoon to make, and then probably a day or 2 to debug. And so what we're trying to do here is take all the tedious work out and allow you to just do what you need to do, which is define what type of systems you want. And if you want to change the fan, you can actually delete this fan and add in another fan. Or for example, I can add in evaporative cooling. So I'm going to find evaporative cooling. And again, my background's in architecture, so I might do silly things like try to drop it on the demand side. So Energy Plus only allows you to do certain things to make a runnable simulation. And as much as we can, we try to protect the user from putting things in the incorrect place. So if I drop it on outside air, which is what's happening over here, it allows me to put that there. So that's how the mechanical system works, and then you can run the simulation the same as it was. with the ideal air loads. And by the way, when you put one system on, it disconnects another one to do that. So let me jump to constructions here. And please unmute if you do have questions, but like I said, we can go back to those. So I'm going to purge some unused objects out of this model. Basically, the templates were preloaded with construction sets for all these different vintages and climate zones. And in the end, I've put my building in, well, actually, I've made it's in a single climate zone for the 2009 vintage. So it'll take it just a second to clear out these unused ones. Okay, so now we are left with the one that we are using. And when I click this, it brings up this list here. And we have the exterior surfaces, interior surfaces, ground contact surfaces, and then we have subsurfaces. So we can actually set different constructions for fixed windows and operable windows. And in the Sketchup plugin, you can then assign a window to be one or the other. And then again, we have glass doors, overhead doors, and just a standard door. And then skylights have their own construction set. And then TDD devices. And so in this particular project, I don't have any overhead doors. But if I did, I could go to my library, and I could look through the constructions. And so maybe I want to use the same thing I would use for an interior window, which would be a bad choice. But just as an example, I can drag this over on my overhead doors. And so if I do have an overhead door now, it will come and get this construction. But I'll delete that one out of there. So if I ran my model with so this particular building is running with a pretty current window. It's based on ASHRAE 189.1 for climate zone 4 and 5. Let's say I'm modeling an older building. I can go look through my constructions here, and I'm going to look through the ones in my model as opposed to the ones in the library. Okay, so here is 5B. So this is well, that's an attic exterior roof. I want a window. Okay, so here's a building that was built before 19. I'm still not on Windows. That's all right. We'll pretend this is Windows. I'm going to take this construction and I'm going to drag it over for fixed windows. And so now it's showing that new construction here. And so you can just change that, and anywhere you have those windows, it will change the construction that gets applied at runtime, and you can do an analysis of changing out all your windows or a certain subset of your windows and seeing how the simulation changes based on that. So this is much easier than in the past where you had to go back into the SketchUp plugin, select every surface, and manually reassign a new construction for it, which well, my model's closed, so I won't go back to do that. So we also can go in, and actually the SketchUp plugin is probably the best place to show this. You can also edit constructions and materials. The interface in the OpenStudio application doesn't quite show that yet. But if I go into the inspector here, then I'm going to show you the different ways you can define a window. And these are defined by Energy Plus. So there's something called a simple glazing system. Actually, let me load in a template here. I'm just going to load in that large hotel template again. It has some sample constructions. But there was a question basically what inputs go into defining a window construction. So we have something called a simple glazing system, or rather Energy Plus has something called a simple glazing system. And it's pretty easy. You give it a name, and actually this name isn't, the name happens to match the objects below if it was in the correct units. But the name could be anything. The important things are the U factor, the solar heat gain coefficient, and the visible transmittance. So you can just set those three values and then use that window. Energy Plus also has a far more advanced construction that has a lot more inputs. So you have a lot of inputs related to the reflectance and transmittance from front side, back side, and then conductivity and then a number of things. So anyway, you can use either of those, and I believe Energy Plus has a number of additional ones. These are just the two that our templates are preloaded with, depending upon what vintage you're using. So if you don't want to use the building component library, you could go and you could just edit your U value of your window manually within the SketchUp plugin. So I'm going to show how schedules work. Some of these tabs, and constructions have had this too, we have subtabs. So when you want to drill in deeper, you just go to these tabs to the right. And so I'm going to go, this top tab here actually just lets you choose what day of the week you want the year to start on, and then you can change the settings for daylight savings. But if you drill down to the Schedule Sets tab, this is the one that defines a lot of the building activity. So if I go to the large hotel retail schedule, we have a schedule for number of people, activity, lighting, and electrical equipment. And then if we scroll down, we have infiltration as well. There is no gas equipment here, but again, similar to what I've done everywhere else, I can just go find my schedules, and if I want to drop a gas schedule on there, which we have for the kitchen or laundry, I can drop that over. And then that will be used anywhere that space type is assigned, or that schedule set is assigned. And if I want to actually look at a schedule itself, I just drill down even deeper. And here I can pick a schedule. Let's find a nice one here. So here's a cooling set point schedule. Now these schedules have rules that go associate with them, and so when you click a rule, you get a profile. This one's not that exciting. Let's find one that's a little more interesting. Okay, here's the lobby occupancy. So this one has a series of rules. Now each time I click on a rule, which this one's the priority 2 rule, it shows you 24 hours of a day, and then it shows you a value, which in this case is a fractional value between 0 and 1, but it could also be degree temperature or some other type of number. And so what this shows is at roughly 5 in the morning, the occupancy goes up, and then it steps up again later, and it peaks out at 0.7. I can actually manually drag this up and down, or I can type in a number while I'm moused over it. I can type in 0.8, and it will type in a precise value for that. So this is where you can adjust the operation of the building to match what your building has. And for daylighting, if you can start doing lighting controls, this could be valuable to look at how the operation of the building has an impact on the design that you have for it. So this is also operating just Monday through Friday. The blue colors tell you when this rule was applied, and this one runs from January 1st through December 31st. But for example, in a school environment where you have different occupancy and operation in the summer, you can change this to be certain, just run certain times of the year. Now on the right, you see an annual calendar, and you notice you have this darker purple and then this pink color. Those correlate to these rules. So this priority 1 rule is what happens on Saturday and Sunday, and you have less occupancy. And so that's occurring where you see it on Saturday and Sunday throughout the entire year. If I decide that I want to operate the same way on Monday, I can actually click Monday. And because this rule is priority 1 above the priority 2, it takes precedence. And even though both rules apply for Monday, this one wins out. And you can see a visual indication of that over on this calendar that you can scroll down through the entire year. Now also, if I decide to turn off Saturday or Sunday, you see this blue indication to tell you that basically you don't have a default profile for that. And so we have a catch-all here that picks up anything that doesn't have a rule applied, which in this case is set to 0. So if you want your occupancy never to be below 0.2, then I could just change this to 0.2. And then whenever you see this blue, light blue, it would pick up that profile. And again, I didn't explain how to split up this profile, but if I double-click, I can split it up, and that's how you can start adding more fidelity to your calendar. And right now, the smallest step I can make here is an hour, but you can actually jump ahead to 15 minutes or even to 1 minute. And this bottom becomes a navigation tool, and it allows you to do smaller time steps with higher fidelity for your model. So I think that's all I want to show on the calendars. Loads are definitely worth mentioning. So this is where you define people and lights and gas and electric equipment and any other equipment you have. And so there's a number of ways you can enter this. Most of our loads in our templates are kind of a watts per square foot. So for lighting, it's lighting, power density, and for people, it's just people per square foot. However, as the design advances and you know that you have exactly 8 lights and you don't want to put in a watts per square foot, but you want to put in 8 lights that have 50 watts each, you can go in, and I'm going to actually just change to a lighting object here. And I can just erase this 0.62 watts per square foot, and I can just type in 50 watts here. Now this is just defining an object, so it's just a type of light. If I actually want to go and see how many of them I have, what I need to do is go down to my space types. So the space types is another type of resource. And the space types really adds together the three sets of resources you saw above for the schedules, the construction, and the loads, and all those go into a space type. And so if I look at the space type, this is an attic, so it doesn't have lights, but if I pick another space type that does have lights, here's where I can come in and put a multiplier. So this might be where I have 15 light fixtures that use 50 watts. So that would define a more detailed model. Again, like we saw with constructions, you get this little green color here. This indicates that this schedule is inherited, and it's inherited from the schedule set that's used here. So every space type typically has a schedule set associated with it. It can have a construction set. We generally don't use that, but an example would be if you're doing a medical building that has X-ray and you want to have lead walls, you can assign space types to have constructions that go with them. But right now, we typically set that at the building level. But if on this particular light you want a special schedule, you can drill down and you can find a schedule rule set, and you can drop it on to override what would be inherited by default. And if you delete it, it goes back to the inherited one. Another thing to point out here too is that this has one type of person object, one lighting object, and one electrical equipment object. You can actually add multiple light objects into the same space type. So you can have lights, task lighting that has its own schedule and usage pattern, and then you can have general lighting as well. And so the same goes for if you want to track staff in the building separately from visitors, you can have multiple people objects that you can change into, they still add together to the same loads. So I think really that's all I want to show there. I'm trying to think. There's some advanced tabs here that you may not use, but it's worth mentioning what they are. If you want to look at that results viewer application that shows high, time series data, this tab here populates with the commonly used variables that people might want to request. So if I want to look at, right now I have surface temperatures on, but I'm trying to find another example I might want to do. So if I want to see relative humidity, I can turn this on, and then I can change the frequency that I want it to report. And typically you can leave it at hourly, but you might want to do it more detailed or maybe back off and only do it monthly. This next tab here is coming down the road, and this is going to allow you to run partial year simulations and change other options. The scripts tab is pretty powerful. And what this does is some of those building measures that, for example, the window-to-wall ratio that I applied in the Sketchup plugin can also be applied here, and it can run on your model just before it runs the simulation. So you can have a series of these measures you like to try from time to time, and then when you find one you want to use, you just go to the library, and I can find, for example, a model script here, set window-to-wall ratio, and I can just drag it into my model. And when I click that, I can populate the arguments. Okay, well again, I'm using a development build here, so it should pop up an argument that asks me for a window-to-wall ratio fraction and then also the orientation that I'd like to apply that to. So what this allows you to do, though, is in addition to automating those kind of tasks, there are certain things that Energy Plus can do that OpenStudio cannot. And this allows you to inject those, so you can inject scripts at different stages of the run process. So just to back up a bit, we're working in a file format called an OSM, which is an OpenStudio model. Energy Plus doesn't accept that file. So when we click the button to run a simulation, we export that to an IDF file using a translator, and then we hand that IDF file off to Energy Plus. It runs a simulation and produces a SQL file along with some other files, and then we feed that back into OpenStudio to present those results to you. So you can run scripts on, for example, the OSM. These model scripts run on the OSM file. But if you want to do something that OpenStudio doesn't yet support that Energy Plus does, you can go to the IDF scripts section, and you can find a script here that will wait till the file has been translated to an IDF file. It'll then apply a script, run the simulation. So
a good example of this is Energy Plus can simulate electrochromic glazing, for example. You can't directly apply those kinds of properties to the constructions in OpenStudio, but you could write a script that you could load here that would make those changes to the Energy Plus model, the IDF model, that would enable that kind of dynamically changing window, as just an example. So we're trying to give people the ability to stay in OpenStudio, but do things to the Energy Plus model that we just don't directly support yet in OpenStudio. So that's the idea behind this scripts tab.
Okay, so I think I've kind of gone over this application pretty well, so I'm going to probably hand it back off to Rob to talk about Radiance, and then we should have some time for questions. Do you want your slide deck up for this?
Sure. All right, Rob, there you go. So I alluded before to the this Radiance integration stuff. I just want to talk a little bit more detail about it. Daylighting is a key component to any net zero or even just high performance building design. But the current energy simulation software like Do2 or Energy Plus are pretty limited in how they can simulate the lighting. Both the electric lighting, it's kind of load based. It doesn't really have any spatial sensitivity. We're not modeling luminaires at an individual light fixture level. It's just a load for a space. There's a lot of geometric configurations that an architect might want to construct to help daylighting get into a building, but a lot of those can't actually be, the light transport through those spaces can't actually be simulated with a lot of the energy simulation software. And then the algorithms that they use to compute the daylight resource and the electric light response are crude at best. There are good lighting simulation tools out there, Radiance being probably the gold standard, but there's also commercial software like AGI32 and 3D Studio Max Design, which is an Autodesk product. The problem is all of those are disconnected from the energy simulation. It's a completely separate simulation tool. It's a completely separate model. It's probably a completely different modeler. So that the problem with that becomes keeping the model synchronized. Keeping the assumptions about the glazing transmittance or the wall reflectance, for example, keeping those synchronized across the multiple models becomes a headache. So that's why we're trying to incorporate it right into OpenStudio. So you have an OpenStudio model that has, and I alluded to this before, there's certain constructions and objects in the OpenStudio model that are relevant to a Radiance simulation that have no bearing on an Energy Plus simulation. The idea is that the OpenStudio model is sort of the mothership, and all of everything from the geometry to the assumptions about the constructions, and again the glazing transmittances, the weather file, the site location data, all that stuff is in this OpenStudio model. And then when it comes time to actually do a simulation, OpenStudio handles the creation at runtime of a Radiance model to do a daylight simulation, or an Energy Plus model to do the whole building energy simulation. So right now, today, OpenStudio supports a direct translation of an OpenStudio model to a fully valid Radiance format. Material data, weather, site, geometry, and schedules, too, is an important one, are all derived from the OSM. We're leveraging the daylight coefficient method to do the annual daylight simulation, and we have support for what I'm calling simple daylighting controls. So right now we're just evaluating illuminance at the work plane, and when that set point is met through daylight alone, the lighting power fraction is at 0. When it's not met at all, the lighting power fraction is at 1, and if it's somewhere in between, it's somewhere in between. So it's a pretty crude lighting simulation or daylighting control simulation, but it's really no different from what tools like DaySim do today. We are working on advanced lighting controls and also some daylight metrics reporting and glare evaluation, and those are actually not going to make it into the 080 release. They'll make it into the 090 release at the end of September. So this is just a graphic example of what I was talking about earlier about these air walls. So the image on the top shows what a typical energy model would look like. You can see some actual hard walls that are actually just zone boundaries. So they don't actually represent real physical barriers to the daylight, but that's how they're represented in a typical energy model. So in OpenStudio, we have the ability to tag those thermal zone boundaries as air walls, and so they're rendered in the lower image is sort of a translucent. That's just to give the user some feedback as to how that wall has been defined in the OpenStudio model. And then we also have these interior partition surfaces, which we've applied here to define little perimeter offices. So again, this is the idea that there's stuff in OpenStudio that we need for Radiance, but we don't need for Energy Plus. And this is sort of how we're handling that kind of co-simulation modality, where we're relying on Radiance to do a real valid daylight simulation and then passing off that daylight performance to the Energy Plus model to characterize the rest of the building energy use. I mentioned before the daylight coefficient method. Basically, what we're doing when we leverage the daylight coefficient method is, rather than solving the lighting solution for a specific time of day or day of year or sky condition, we actually solve. We figure out what's the contribution of considering a single completely uniform sky that just uniformly emits 1 candela per meter squared per steradian. And we solve, well, what is the contribution for a number of different sections or zones of the sky or patches of the sky? And then we can, once we solve that, which takes about as long as a typical Radiance simulation for a single point in time, but once we have those coefficients, we can then, on the fly, generate a sky that's representative of any particular day, time of year, sky condition, and sample that sky and then multiply the actual sky radiance for all those patches against the daylight coefficients and come up with a result. So the initial simulation can take 20 minutes to 2 hours, depending on the complexity of the building, but that one simulation can then generate actual valid daylight results for any sky condition and time of day in about 3 to 5 seconds. So whereas in the past, people would, when they did daylight simulations with Radiance or AGI or whatever, they would just kind of look at a few key times of day for the year, like maybe just look at 3 or 4 hours for the solstices and the equinox, and just sort of make some extrapolations based on the performance of those key days. But with the daylight coefficient method, we can actually look at the daylight performance for a particular building, for a particular building component, such as a window, for every hour of the day, for using climate, site-specific climate data to get a much more clearer picture of what's going on in terms of the daylight performance. I'll just blow through these. This is just how the Radiance integration is embodied right now. It's not. It's been done through using writing Ruby scripts to use OpenStudio sort of on the back end at the command line level. So this is how we can translate an OpenStudio model to a Radiance model. There's a fairly complicated simulation tool called DaylightSim.rb, which allows you to generate these daylight coefficients that I just talked about and also do an annual simulation. We have another script called Make Schedules, which you basically just, you take an annual illuminance profile that's generated with DaylightSim and give that plus an illuminance set point to this Make Schedules program, and it basically just does an evaluation at each time step to see what the daylight illuminance is, what the set point is, and it basically modifies the lighting power fraction based on how well the daylighting is performing for that particular hour. And it basically just creates a new OpenStudio model with this lighting schedule injected into it, which you can then run through Energy Plus to get your whole building energy simulation, energy use, but it's using the lighting schedule data based on this Radiance simulation, which is far more efficient, or far more accurate, rather. And then annual plot just generates those temporal plots, which I showed an example. Here's another example of the temporal plots. So these are annual snapshots of daylight performance of a particular building model. The image on the left is the model has clear windows, clear south-facing windows, and no blinds are being operated. The image on the right is the same exact model, but it shows what the impact would be if the building occupants actually lowered the shade whenever there was direct sun on the facade. So you see quite a different story in terms of what daylight is available in the space when the building is being operated by actual human beings. So it's a little bit more. The image on the right is a little more truthful in terms of how much usable daylight is probably going to get into that space. So, and that's another thing that the daylight coefficient, the three-phase daylight coefficient approach allows us to do, is to do these kinds of simulations where we can change the configuration of the windows at every single hour. So this allows us to do, in this example, it's showing the impact of a user operating a blind or a shade, but we could just as easily use this to represent electrochromic glazing, changing its tint state, or thermochromic glass, or just other types of blind scenarios. So we feel like this is a very important capability that we're taking advantage of in Radiance through OpenStudio to much more accurately characterize the daylight performance of the building with actual occupants. And I guess that's all I have. Yeah, that's all I had on the Radiance piece. Did you have more demo stuff?
You know, there was one thing I want to show that's just going to take 2 or 3 minutes, and then we can go to questions. I wanted to make sure I pointed out how Building Component Library works. I had mentioned this website. You can browse it when you're not logged in, but the way it works is you can just go and search. So currently, we don't have a lot of real products in here that would be something you'd buy. It's more code-driven or standard-driven windows. So it's, for example, a window that meets ASHRAE standards for a specific climate zone and a specific vintage. So when I run a search, we hit 28,000 objects that were tagged as ASHRAE. Now, if I look here at component types, we can start to drill this down more. So maybe I only want to do fenestration, right? So now we're down to 801 objects from 28,000. So this is the way the users can kind of drill down to what they want to find pretty quickly. So you can also filter by, for example, I think location or climate zone. So let's see if those show up. So if I know I want climate zone 5B, now I'm down to 51 objects. And every time I drill down to fewer objects, it shortens the list of attributes that are appropriate. So you don't have, so there's only attributes here now that are appropriate for fenestration, although doors are still included at this point. And then in some cases you can do a range where if you wanted to go between 2 and 4, well 3, let's say. So once I get one of these I like, if I'm using the website as opposed to the interface, I can actually click on this to get more information about this. And you can see this in SI or IP units. And if it's appropriate, it can be an image or even a 3D model that gets downloaded with this. And here's where you can see users can rate this and provide comments about it. And then when you click to download it, if you're logged in, you won't get this disclaimer, but the first time you log in, you'll have to accept this. And then it basically downloads various elements, but the component data is the actual OSM file that will get loaded into your model. And in this case, it's just a construction. It's not the geometry of the window. So I just wanted to show how that works. Our plan eventually would be that manufacturers can have their own content here, and they'll be able to upload it to the server. Currently, though, because we're in beta, it's still just populated by us, and it tends to be more research-related objects that are based on standards.